So, as a past accountant, Philip is always concerned with maximizing revenue and efficiency. He was able to take raw van rental data and transform it into a time series analysis to forecast sales and illustrate the effects machine learning can have on businesses. Philip, take it away.
Can you hear me?
Perfect.
You can now.
All right, sorry. All right, can everyone see my screen? Head nod, yes. If that's it. All right. All righty, let's get this thing going. Hello, everyone. My name is Philip Vargas. All right. Hello, everyone. My name is Philip Vargas. My background is in finance, accounting, and healthcare.
Hey, Philip, I still can't see your screen.
Oh, you still can't see it? Sorry.
No worries.
There we go.
Awesome. Perfect.
All right. Sorry about that, everyone. All right, let's get this thing going. Hello, everyone. My name is Philip Vargas. My background is in finance, accounting, and healthcare. My project is titled Van Rental Fortune Telling. What is a van rental company's most crucial business component? If you guess vans, you guessed correctly. Fleet size for any rental car company is the largest and most volatile business expense. Fleet size is a variable of sales demand, meaning sales demand predictions are vital to the company's success. When predictions are too high, the company pays unnecessary car notes and storage fees. When predictions are too low, the company loses revenue opportunities. Now visualize a world where you have the optimal fleet size at every peak and slow period. Now imagine if all this could be done with a fraction of your current effort. The purpose of this project is to turn those visions into a reality. I set out to build a model that can accurately predict sales demand with minimal human input. I partnered with a nationally operated van rental company. They were kind enough to share with me 3 years of raw revenue data, which I converted into a time series data set. The first step for any good data scientist is to perform exploratory data analysis. On the bottom left, the bell curve shaped histogram indicates sales follows a normal distribution. In the box plot on the top right, we can see the monthly seasonality via the wavy shape. Lastly, in the bar graph on the bottom right, we can see the daily seasonality, with Friday being the peak day. Shameless plug, in another project of mine, I created an algorithm that can classify a data's probability distribution. I use this tool to confirm my EDA analysis of this data set's distribution. It works. Visit my GitHub if you're interested. Moving on. There are 3 types of time series input-output types: sequence to sequence, sequence to vector, and vector to sequence. We're going to focus on sequence to sequence type because we are predicting sales. Listed under libraries are the 4 libraries I decided to use, but there are several more libraries out there for performing time series analysis. I created over 700 plus models using the 4 libraries. This table shows the basic model and the best tuned model from each library. This table also displays the algorithm name, the model parameters, and the RMSE score. RMSE stands for root mean squared error, and it is the measure of prediction error. The lower the error, the better the model. Facebook Profit tuned model performed the best. Now let's discuss the winning library and its results. Facebook Profit was the easiest library to use, primarily because it does not require data to be stationary, meaning the trends and seasonalities do not have to be removed from the data. The horizon time indicates the number of days I wanted the model to forecast out, and I used the holiday hyperparameter to account for US holidays. Now the graph on the bottom left, the black dots are the actual number of vans rented, and the blue line is the prediction for the number of vans rented. I think the model does a pretty good job of following the signal of the actual sales data. On the right, you can see my train test split results. I use 70% of the data to train the model and 30% of the data to test and evaluate model performance. Again, the blue line represents the predictions and the orange line represents the actuals from the test data. The blue prediction line and the orange actuals line overlap nicely, indicating that the model is performing well. Next, I ran an experiment with my model. I used actual fleet availability and the model's predictions. Now let's establish the experiment reality. First, cars can be purchased and sold every day with no lag. Second, there is always an immediate buyer when vans are being sold. Third, there is always immediate funding when vans are being purchased. Next, let's establish the rules. First rule, optimal fleet availability is double the predicted demand. Second rule, anytime fleet is greater than one, but less than optimal, the company will benefit $400 per car. Third rule, anytime fleet is over the optimal mark, it will cost the company $400 per vehicle. And fourth rule, anytime fleet is in the negative, it will cost the company $400 in revenue per vehicle. Now, the experiment results were fascinating. The first thing I noticed is that the highest amount of overfleeting costs happens late December to early January. Next, I observed performance between man and model oscillated between profit and loss. Ultimately, if the model was deployed, the company would have saved $360,000. For this van rental company, complete fleet automation may be too ambitious, but augmenting fleet decisions is very possible, and it would contribute immense value to this organization. This is the tech stack I use, some of the libraries and packages that I used. And this is an actual Tableau dashboard that I created. Now, this is a very popular visualization tool in the industry. A dashboard like this could be utilized by companies' non-technical employees to observe the results of some of these very technical time series analyses. And that's my presentation for today. Thank you. Any questions?
And for this portion, go ahead and just open up your chat and it will default to our resident Ellie and she will read out your questions.
So there is one question coming. So what's the methodology did you use to make 700 models?
I use the looping method. Python is great for looping. So a lot of the Facebook profit parameters and a lot of the other packages, it's digit based, and you can increment it via like decimal points. So 0.1, 0.2, all from 0 to 1. I just looped through to really see what was the best.
Okay.
Any other questions for Philip?
Oh. Okay, so there's a great job. Why would you not be feasible for the current company to implement your model?
Say it one more time, Ellie. I'm sorry.
Okay, what would be not be feasible for the current company to implement your model?
Oh no, it's absolutely feasible. So the comment that I made was that it may not be feasible for it to be completely automated, just because something as important to this particular business model as fleet, it's like, okay, there needs to be some trial and error time. So to say complete automation without any human interaction with it would just be irresponsible, and I wouldn't suggest such a thing. But actual augmenting, like helping them make decisions based off of actual data and real statistical analysis, then I would highly recommend, and it's completely implementable.
Okay, there's another question. So why did you have a train test script of 70 versus 30?
I think I might be lagging. Can you guys hear me?
Oh, yeah, so there is another question, Philip. Okay. So why did you have a train test script over 70 and 30?
Well, my data set was finite. A fun fact, I actually performed a little accounting work to actually get that data. So, you know, it's a finite data source. So anytime you're training a model, you don't want to show the model 100% of the data. So you always want to use more of the data to train, and then you save a little bit at the end so you can actually evaluate how the model performs on unseen data.
Awesome. You have one more, Ellie?
Yeah, there is a three more too. Okay, so another question. What input variables did you use for the model?
Say it one more time, Ellie.
What input variables did you use for the model?
What input variables?
Yes.
So time series, the input variable is, since it's time series, is time. So everything is time dependent. So that's pretty much what's used. But if we're talking about like the output, we're talking about actual sales demand, not sales dollars. So it's the actual number of contracts generated per day.
Okay.
Awesome. I think that's enough time for questions. So thank you, Philip. Great job.
Thank you.
We're gonna
Yeah, great job. A nice explanation, everybody say.
Thank
Philip.
you.
Mm-hmm.
Let's save money.
Awesome. Great. So